So here goes the solution file for the shopping spending score exercise that all of you did. So if you remember the data set that we had two features. We have the income of the customer and we have the spending score of the customer. So for every customer, we have two features. We have the income of the customer, we have the spending score of the customer, and we are trying to find the different groups and clusters of customers. Okay, so this is the clustering exercise that we are trying to do. How did we go about it? First step, we think we go and do the elbow method. So the elbow method is clearly telling us that there are total 5 groups or clusters of data. We can clearly see the bend. We can see the inflection point. That means when clusters is equal to 1, the inertia is very high. When we go from clusters 1 to cluster 2, inertia has dropped. When we go from 2 to 3, inertia drops further. When we go from 3 to 4, inertia drops further. When we go 4 to 5, inertia drops further. So we can clearly see that as we increase the number of clusters, the inertia keeps dropping and dropping and dropping until we reach an inflection point. And that is where we can say that we have the optimum number of clusters. Now, the moment we have clusters equal to 5, from here onwards, you can see that there is no further reduction of inertia. So once you touch the inflection point of 5 clusters, from here onwards, even if you increase the number of clusters, you can see it is not improving. The overall inertia remains roughly the same. So now that we know that clusters is equal to 5, we are saying n clusters 5. So we build those 5 clusters. This is the final data frame that we can create, where we had the original 2 features, which is annual income and spending score. And we have added one additional column called the group. So the group is going to tell us what cluster or what group that particular customer belongs to. So this customer belongs to group 1. This customer belongs to group 4. This customer belongs to group 2. So this is the final part of the clustering that you can go and do. And based on the question that one of you are asking, the final part will be, after you've done the clustering, now you can go and identify what are the different groups and clusters of data. How do we interpret the groups? So you can create a pair plot, and you can create a pair plot or you can create a box plot, and based on that you can interpret the different groups and clusters of data. Okay, the pair plot is clearly telling us that it's able to identify what those clusters mean. An even better way of doing that is actually using a box plot, where you can clearly see and you can compare between the different groups and clusters of data. It's the last part, how you try to interpret the clusters. And you can see that cluster 0, cluster 1 group of customers typically have high income and high spending score. On an average, the customers who are part of group 1 have high income and they have high spending score. Whereas if you look at customers in group 2 on an average have low income and low spending score. Now, what is very interesting are groups 3 and 4. 1 and 2 are kind of the two extremes, right? One is very high engagement, one is very low engagement. So somehow these customers are not spending. And but what is very interesting is groups 3 and groups 4. So if you look at group 3, who are the group 3 customers? Group 3 customers are those customers who have very high income, but who have very low spending score. That is the group 3 customers that we have. And if you look at group 4 customers have low income and high spending score. That is what we can say about group 4 customers. That is the inference we can make about the different types of clusters. And based on this insight, we can go and further develop business strategies to run our business more efficiently. See, for example, if you come across customers in group 3, now group 3 is a concern, right? Because these are customers who very clearly have on an average a lot of income, but for some reason they are not spending with me. So they have a lot of disposable income with them, but they are not coming to my store and spending money. What could be the reason? Maybe it could be because I'm not stocking enough products which are preferred by this particular group of customers. The other thing is also very interesting, like customers who have low income but high spending score. Now these are like very, very loyal customers, right? These are customers who are very budget conscious customers. They are not the highest earners, but despite having a lesser amount of money, they are still spending a lot of money with me, because most likely this could be that they are coming from a different state and they're mostly freshers. Let's say they're still yet to settle down with families, and they're still buying a lot of items outside. Let's say grocery shopping. You go to usual shops and do grocery shopping. This could be some very interesting discoveries you can make by looking at your data. Again, in all these examples, if you see, we don't have any labels, but we only have the features, we only have the data, the inputs that are available, and based on that, we are creating groups and clusters or segments of customers. And once we identify that, once we see that, hey, we are able to group our data into 5 clusters. Now we can try to come up with different promotional campaigns for each of these different groups. So now we can say, hey, you know what? This group 4 is like a very loyal group of customers. These customers deserve more from me. If you're the store owner, you will look at this group 4 and say, okay, these customers are, they are like my like my bread and butter. Despite having less income, they're still spending in my store. So maybe tomorrow or a year later, if their incomes increase, they will continue to spend more. So we are trying to build that loyalty aspect with these customers more. So maybe for the group 4 customers, every once in a while, every week, you will give them some nice promotional coupons. Even something as simple as, let's say, you buy 100 rupees worth of grocery, and we will give you a 5 rupee, something like 5 rupee salad for free, something like that. People would love it. They say, okay, this is a good store. Whereas if you look at this group, the group 1 customers, see, the group 1 customers are very rich people, right? They are rich people, very high engagement, high income, high spending. So these customers don't want discount, but these customers basically want a good, probably they want they want a very good experience. So maybe next time you are having all these so-called, new launches, like the way Amazon, Flipkart, they do new launches. Then there's a new smartphone launch, like you have those first day sales, those exclusive sales that can happen. So maybe this kind of group is looking forward to some kind of an exclusivity. Maybe have a membership tier, start a membership card process, like what Zomato did long back. They started this thing called Zomato Gold, right? There was a Zomato Black membership. Now there are different memberships that have come, but Zomato was one of the pioneers of this, this concept. And they even came up with a credit card. This was back 3-4 years back. There was a RBL bank credit card they used to give out. If you have a Zomato Gold membership, you have this edition. There was a Zomato edition credit card that they came up. Then they eventually stopped it. It's been almost 2.5 years they have stopped the credit card. But these were some very interesting strategies that you can come up with as a business once you are able to see the different groups and clusters of customers. So especially for these kinds of customers, I want to give them some more some more exclusive deals. Some maybe Swiggy. A lot of these co-branded credit cards are there, right? So maybe you can divide it into tiers, right? You can give them a very low end Swiggy co-branded credit card if you're a low engagement customer, like a something like a group 2. But maybe something like a group 1, you can give them a really high end credit card, let's say with some free lounge access and all those kinds of things. Okay, so these are some very practical ways how you will approach these problems going forward. Okay, coming to the next case study. The next case study was very interesting, and I will take a minute to take you through the case study first, and then I will explain to you. This is a again, the core concept is very similar, but as I say, the next case study, the focus is mostly on the feature engineering aspect. And this is the general context of the case study. So we are looking at a real data set. This is again a real anonymized data set that we are exploring, which has transactional data from 2010 to 2011 for a UK-based registered non-store online retail. And you can see this is my data. Once again, invoice number, stock code, description, quantity. So this is effectively what my data looks like right now. Okay, so let me take you through the solutioning. This is my data set. I've already shared that with you, and I'll take you through the whole solutioning approach, what we have done. And again, the focus will be much on the feature engineering part. How do we take the data? How do we identify the features? So we'll try to focus more on the feature engineering side. Okay, so please, like I've shared all the solution notebooks with you. While you're referring to the notebooks, I would like you to refer to the part 1. Okay, the step 1 part. Okay, yeah. So yes, so you can focus on actually the step 2 part. Yes. So initially, my data is given to you in a transactional form, where every row is like an order. So when you place an order in Amazon, this is exactly how your data is captured at the back end, right? You will have something like an invoice number, a stock code, what you purchased, what description of the item that you purchased, how many you purchased, when you purchased, what was the price of the purchase, which customer purchased, like that, so and so forth, right? So you can see we have got invoice numbers. Against the same invoice number, we have multiple items that were purchased, right? So that's the inference we can make out. So you can see again the same invoice number. So it's for 536365 for the same invoice number. We can see there are multiple items that were purchased, and it's possible, right? For the same order ID, you do multiple products. You purchase multiple products against the same order ID. So in the same order, you buy soap, you buy shampoo, you buy oil. So these are the different items that you purchase against the same order ID. This tells you how many you purchased, when you purchased, at what price you purchased, and so on and so forth. Right? That's the inference you're getting. Now, the first part of the analysis is you have to understand. That's why I always say that understanding the problem, framing the problem is very important, which is the whole idea of giving you some time to think through the data set. So don't just jump into a solution, because see, if you try to apply the k-means clustering directly on this data set, it will not work. Because what is the granularity of your data? What is the level of detail of your data? The level of detail of your data is actually order level detail, right? Actually, to be more technically correct, it is invoice and stock level detail. The composite primary key of your data set here is invoice number, comma, stock code, isn't it? If you see every unique, what is the unique ID of this, of each and every record? It is invoice number, comma, stock code. You're looking at order level data right now. So even if you apply the k-means algorithm on this particular data set, you will not end up doing customer segmentation. You will simply end up doing what? Even if you apply this in the data set, you will simply end up doing order segmentation. You will not end up doing customer segmentation. You will simply end up doing segmentation of orders. These are orders like this, these are orders like this, these are orders like this. So in order to do customer segmentation, what do you need? What do you really need in order to do customer segmentation? You need to group this data into customer level of detail. There's a whole lot of feature engineering we are talking about. So we take the original data, we try to do group by, we group by customer ID, and we try to find out three key metrics, three key things we try to find out. Okay, this is an example, but you can do much more. Feature engineering is a very broad universe, and you need domain knowledge to do this. It's very subjective. It depends on your field of work. So here what we have done is from the original data, we have done group by customer ID, and we try to find out how many orders you placed. This is the most basic one, right? Group by count star. So group by customer ID, do a count star. So for every customer, we are tracking how many orders they placed. We are finding out something called monetary value. There's something called monetary, which tells me the total value of orders that you placed. So for each and every customer, group by customer ID, we are basically doing a sum of amount. What is the total amount that you place, which is in itself is unit price into quantity. Remember, these are the original features we had. It is like we are doing group by customer ID, sum of unit price into quantity. So in a way, for every customer, we are looking at how many orders you placed, total value of orders you placed, historically, ever since you opened the account, how many overall value of orders that you placed. And finally, we are tracking how many days back you last placed the order. This is actually very interesting. This is called recency. A lot of companies, they measure recency. Recency is used as a very useful attribute to understand the active status of the customer. See, for example, I'll tell you something. I last ordered in Amazon long back. So my recency is very high. Let's say I last placed an order 1 year back. So Amazon will look at the current date time. If you look at my last order date, and it will find out the difference in days, and that's the recency value. So for somebody like an Amazon, the recency value is nothing but the current date time minus the last order date. So 365 is the recency value. So for example, this customer, the recency value is 325. That means this customer is currently not active in the platform. Another way to look at it and explore this would be, this customer is presently not active in the platform. So now your objective would be, how can you make these customers, how can you make these customers more active in your platform? What can you do? Because right now, very clearly, as you can see, this customer is not active in the background, in the platform. So very clearly, this customer is not active. So now you have to figure out what you can do to make this customer active. What are the different things we can do to make? So, which is why if a customer's recency value is high, you will often see that the brand will want to offer more discounts to these group of customers. If you have not used Amazon for a long time, if you do not use Swiggy for a long time, okay, let's say Swiggy has Instamart. So you try not using Instamart for 1 month. Swiggy Instamart will give you a free 100 rupee coupon. Why? Because they are sensing that your recency value is very high. You last ordered more than 1 month back. So they are trying to get you back to the platform. They are sensing that you have become inactive. You are probably churned. Churn means you leave Swiggy and you go to some other brand for your groceries. So if they predict that, if they predict that because your recency is high, you're not ordering from Swiggy, so they'll try to get you back. They'll try to give you a 50 rupee voucher or something. So then they will force you to shop. And it's a behavioral thing. Like you shop once and you feel happy, you shop again, and it's a very behavioral thing. But it's quite incredible how these things are actually used. Segmentation, customer segmentation and clustering is at the core of how we see all these promotions, discounts, and how all the grocery, hyper local delivery startups and the e-commerce companies are operating. Even to the point of telecom companies, I would say, because everything, but these are some examples we see on a day-to-day basis. Telecom maybe less so, because honestly, telecom is mass market. There's like I I mean uh, but yeah, I mean there's a lot of scope for what you can potentially do. Right? So maybe something like a Reliance Jio or a Vodafone can look at your, or Airtel can look at your day-to-day usage data. They can try to understand how you're using the connection, and they can try to recommend recharge packs and plans according to how you use. So if Jio sees that you have not topped up for a long time, they might give you a 50 rupee coupon to sweeten the deal, because they think you might have left Jio and went to some other platform. Churn, customer churn is another very important problem that companies are solving. Okay. Anyway, so this is the first part of the analysis, because I think this is the most important part, and this is the part I really wanted everybody to kind of figure out. So if you were able to, then it's great. It's good that you were thinking, but otherwise, this was quite a important part of the problem, because once you have this, there is nothing to talk about. Now it is back to the same template that we discussed. So now you have each and every customer. You have the features of the customer. For every customer, you know how many orders they placed, the total value of orders they placed, and how many days back they last placed the order. You know that for each and every customer now. Now that you have, and you can have more features. This is just an indicative solution I'm showing you, but you can absolutely have more features. If you want, you can have more features, like, okay, let's say you can break up the total order value into multiple categories and subcategories. You can say, hey, how many electronics orders were placed? How many grocery orders were placed? Right? How many uh, uh, stationary orders were placed? Something like that. And you can go to even more granular level of detail. You can say, hey, how many orders are placed on weekdays? How many orders on weekends? Total value of orders at night. Night is how you define night. Night is mostly um, 11 to 6, mostly. I think night is 11 to 6, 11 p.m. to 6 a.m. That's also a very interesting category. Who are the night owls? Who are the people who are usually shopping at night? Because I mean, see, these are all behavioral studies. You'll be surprised to know the kind of analytics that these kinds of companies are using, to make people buy more. And usually it is proven that maybe, because daytime we are all busy, no? Daytime we are all busy, we are all doing our work, we are very focused generally, right? So we know what to buy, we know what to do, but usually at night, our mind is idle, we are in our free time, and maybe your probability of purchasing is much more at night. Or let's just put it this way, your probability of getting influenced is much higher at night. So the companies will want to look at that also. So like, for every customer, we want to see what is their total, purchase value, what is their nighttime purchase value, and if Amazon sees that, okay, your percentage of purchases at night is much higher, then you're a night owl. You're somebody who likes to purchase at night. They will look at your browsing time at night. So obviously in Amazon, they will not have your other, like they will see, okay, you're a customer who typically browses the application a lot at night compared to the mean and median averages. And once they do that, then they have a cluster. So if they do a customer segmentation, they will have a cluster. They have a cluster of people who are typically, buying more at night. And now for that group of people, they might want to send out more targeted campaigns for people who are, browsing at a particular point in time of the day. Okay, so maybe give you some offers, give you some discounts. So maybe, as I said, like they will influence you to purchase. So 50 rupees off they will give you, so you are forced to purchase. Anyway, so once we have this, this will be a bigger data set usually. So every customer will have multiple features. And once we have this data set, now we can carry on with the clustering. I've already shared the solution. You can go through this. So back to our elbow method. So we're getting two very distinct clusters, two very broad groups of data we are seeing. And this is a general concept. I talked about this in our poverty data set as well. So, the more groups you try to have, uh, the more difficult the problem will become, the more overlaps you will get. Two is a very clear cut segregation we are getting. So cluster one, cluster two, very clear cut segregation. Now, the moment you go beyond two, you might have a business case. You might have a business objective where you have to come up with more than two clusters. So that is you can't do anything about it. You have to do it. It could be a kind of a genuine business case for having more than two clusters. So you have to do it in that case, right? So that's the idea. Anyways, so this is the solutioning. And once you have the clusters, once you have the groups of data, you can now analyze the clusters. And you can clearly see these are the two broad groups of data we are able to see. So customers in group 0 typically have low frequency, low monetary value, and high recency. So that means customers in group 0 are not very high purchasers. So group 0 customers, you can clearly see, are not very high purchasers. They are customers with less orders, less monetary value, and high recency. They are typically not active. Whereas customers in group 1 are like my cash cows. These are customers who have high number of orders, high monetary value. They have a high value of orders and also lower recency. They are more active. Maybe because they are more active, they are ordering more. They're purchasing more. So a lot of incredible insights you can start to get actually. But the labeling part is something you will have to do. This is a very basic data set, but if you're working with a more technical data set, like your, as I said, networking data, your configuration data, then you will have the business insight. You have to understand, okay, what is this cluster? What kind of signals am I seeing there? And what is this cluster to? What kind of signals am I seeing there? So you will have to sit with a domain expert and understand. Or maybe let's say if I relate it back to the diabetes case study from yesterday, you identify there are two different groups of patients. So patients in group 1 exhibit a certain kind of behavior, and patients in group 2 exhibit a certain kind of behavior. So now you will have to sit with a domain expert and understand, hey, what is that behavior? What is group 1? What is group 2? How are they different? So these are some of the things that you will have to do.